Well, welcome to this panel. We couldn't be happier to have you. My name is Vanessa Generelli, and I am the manager of teacher programs here at Github. And I'm thrilled to bring together this international crew of students who are technical leaders on their campuses to share their expertise with you. And you might wonder, why are students here? This is a teacher conference. What are students doing here? And I wanted to include their perspective for a number of important reasons. One, in my own teaching practice, I know that we're always trying to balance learning objectives and student agency and engagement. And there are these learning objectives that we have to master, this domain knowledge that as teachers, that's on us to help them understand. But at the same time, they need this motivation and curiosity to sustain their learning outside the classroom. My teacher, Mitch Resnick, says that every learning experience is a balance between structure and freedom. And this series of presentations is going to show you how students have worked with their teachers on that balance between structure and freedom to motivate their own learning outside the classroom. And they're going to share with you their passion, which they have in spades. And I know that they have passion in spades because they are all campus experts. Campus experts are technical student leaders who have received training from GitHub Education. With this training, they earn the skills to support their on-campus communities, stuff like technical writing, public speaking, community management. And if you head on over to education.github.com/experts, you can see a map of where the experts are and if your campus has one or not, or if they still need one. And our first up is Amy Dickens from the University of Nottingham. And the way this will work is each student will present their experiences, and at the end we'll have some time for Q&A. So please welcome Amy Dickens.
Thank you. So hello, as Vanessa said, my name is Amy, and I'm from a school called the University of Nottingham in the UK. So I'm here today to talk about how I've used version control and GitHub as a platform for my research at the University of Nottingham, where I study a PhD in mixed reality at the Mixed Reality Laboratory there. So I'm going to cover a few things in my short time that I'm talking to you, and I'm going to talk to you about 4 aspects of how I use GitHub in my research. So I'm going to talk about research in the world of open source and what that means. I'm going to talk about tools for researcher communities. I'm going to talk about a case study of my postgraduate study and how I've been using that to interact with my studies and my supervisors. And I'm also going to talk about how you might take some things away from this talk to help your students develop research skills through open source communities. So first, let's take a look at research in the world of open source. So what do I mean when I say research in open source? Well, there's lots of things that open source is involved in and supports when it comes to research. For instance, there's a ton of industry companies that are on GitHub and have open public projects that people can contribute to. And this is the way that they can develop their projects and products through research. But there's also a lot that happens for social impact as well. So you'll see in the middle there is the GIF for net neutrality, and that's one of the social impact causes that you'll find on GitHub as well. So it works as a great platform to gather communities together and work together in expanding knowledge pools. The other thing that you might find on GitHub as well is individual projects. So I had the pleasure of meeting Aaron, who's a student, an undergraduate student actually at Northwestern, and he'd made a tool for blind users to be able to interact with audio technologies using EQ graphs. And this was great because it was a project that he was able to open source. He was able to put the complete list of requirements on there, how much it cost, how to put it together, the source code, and everything in one repository with a wiki that described everything that you needed to do to make this so that people could access that project online as well. And because he'd done that and open sourced it and had community interest in there, he managed to write a paper in collaboration with his professors and come to the ACM conference in London to present that paper, and got nominated for a Best Paper Award as well. So it's really interesting to see that happening at an undergraduate level through an open source community, because it starts that research interest. And Thirdly, there's also a thing called organizations on GitHub. So you can have an organization where lots of people are affiliated with that organization through their own GitHub usernames. And then you have a place where you can share all of your projects. So whether that's the latest class project or it's a space to put all of your technical projects under one thing, whether it's research, my university has one there, and we have a lot of research under that organization. But it's a great practice to be able to put everybody together and make that a really collaborative space. And that's hugely beneficial to your students as a community, because they can then find people within their organization that are doing similar things. So what about tools? So there's lots of research projects happening open source, but what tools can you actually use on GitHub for that? Now, there are plenty of tools. I'm just going to run you through a few of my top picks. So don't think that it's a limited list. It's not. There is plenty for you to discover on there. So one of my favorite tools on GitHub is actually discovering through Explore. Now, some of you will know GitHub just from a place to put your code and things to do, but this GIF actually shows you that there's a tab at the beginning on the homepage where you can go and explore different communities on GitHub. Now, you can find collections on all sorts of stuff, and you can contribute to those. So there's learning machine learning, or catching up with social impact projects, and as you can see, there's a whole different selection on there. One of my favorites is the music collection, which shows everybody that's doing different digital music technologies, because that's where my research is based in. So you can propose your own collection on this tab as well, and you can add to the knowledge pool of ones that already exist, which is a really nice function. The second tool I want to talk to you about is project boards. So I use project boards in my research. So hands up if you've heard of to-do lists like Trello, or have used agile practices like Kanban boards before, stuff like that. Okay, so GitHub has those features in every repository. So you can create a project board that reflects the whole project, or milestones, or both. It's completely up to you what you do with that. And with each of these boards, you can turn the cards that you add to them into issues. You can add labels to those issues, and you can automate them so that when you close those issues, it automatically goes from your to-do list to your done, which is really, really nice. I love it as a feature because it helps me to coordinate my life entirely. So, and as well as having all of your various like virtual learning environments that you might have at your university, whether that's Blackboard or Moodle or whatever you're using, you can also use wikis to collate stuff like reading lists. So if you're asking your students to contribute to a repository and you want to be able to give them a place where there's also extra reading that might go alongside that repository, instead of having to go back to a VLE or wherever you might have put that or find the last link to that, you can actually have it right there in the repository. So this is a wiki that I've been collaborating on. I co-created a research organization into accessible instruments, and this is about the deaf and hard of hearing community, which is one of the collaborators' points of interest. So they started creating this wiki, I've started creating other links, and it's a great place for then students can add comments or suggestions, like maybe we should add this link, or I found this great resource, and that's a really good, nice thing to build on. The other thing that we have is Jupyter Notebooks. Now, I don't know if anybody in the room is familiar with those, but there is a tool that it's great to communicate, like combining code and data and visualizations. As researchers, it's really hard to find somewhere that you can put all of that thing and it renders as one, purely because you might have to have a link to a code or a demo sample that runs, or somebody might have to download this or do this. And actually, this allows you to just put everything in one place. So they are data-driven workflows, code snippets, equations, text, visualizations, and they result in having really awesome resources that you can put, and they fully render in GitHub. So if you put that into a repository and you click that file, you can see exactly as it was intended from Markdown as well. And that's really helpful because there's all sorts of these on GitHub as well. So there's actually a whole resource for discovering Jupyter Notebooks and resources that are already out there for your students to explore too. So the next tool I already mentioned, but organizations like we had for each of the universities that I mentioned before, it's just a really great way to be able to link everybody under one account. So organization accounts allow you to build together, they allow you to review your code together, track things, discuss, and share. So you can have all of those repositories under one organization, and everybody that's in the organization can have access to them at a collaborator level. So that's just a really nice way of grouping everything together and creating that community. So now you've seen a couple of things that I've seen out there in open source. I want to show you how I actually apply this in my PhD research, which otherwise is a bit of a minefield for anybody that's gone there. So here's how I use GitHub in my work. So for me, hosting, having a Git repository actually gave me a place to have a home for every piece of my work. So I don't lose anything crucial, and I have version control for everything, whether it's the data sets that I've been updating, whether it's the the transcription from all of my ethnography that I've been doing in different places. I have a good grip on when was the last time I went in and updated a file, what's the last commit, give myself messages on all the progress of my work, and being able to store them on GitHub. It doesn't just have to be code. I have my entire thesis on GitHub in a private repository, and I can add my supervisors as collaborators so they know what I'm up to. I can't hide from them, which is slightly sad. But I also make use of project boards. So as I explained before, if you're used to agile methodologies, I use these to help me employ those methods, and I kind of automate my research tasks through this. I even do sprints, not the physical running ones, not much time on a PhD. But here's a glance at what my project board looks like, or looked like a snippet earlier in the month. And you can see that I have everything, it has a blue link because it's an issue. I also have it so it's automated when I close out any one of those issues. It goes to the done pile. So I can either look at my issues as my to-do list, or I can come in here for an overview, which is really useful as a PhD student, because a lot of the time you spend kind of isolated and working through things on your own, and sometimes you need a reminder of exactly where you're at. I also can then add labels, and I talked about this earlier, but like you can label issues with like whether it's a bug fix, or whether this is a to-do, or whether this is a duplicate, you can actually create your own labels, and I do that by timings. So I add times to each task to go, okay, so what's my day look like today? Have I had anybody schedule a meeting with me? Do I need to reorganize myself? And then I can fit my work in around what's actually cropped up in my day. So I can also, when I do my retro, look at this and understand when tasks aren't getting completed. Is it because it's got an all day tag that I'm putting it off and off and off because I know it's going to take me a whole day to do? And at that point, can I decide to break that down into more digestible chunks? Can I be more realistic about how long that's going to take me? And should I be changing those tags? And I also then can group those issues under milestones. So milestones is a feature where you can add like this is working towards this creation, and in code that can be this is working towards that feature. In my thesis, it's kind of this is working towards something. So in fact, when I was putting these slides together, I saw that I hadn't closed out an issue on my second study preparations, and now I've achieved that milestone. So it was really, really fun for me to get that little yes moment. So that's all well and good, seeing how I use it, and some students might be motivated to do similar things, especially in project work. It seems like it works really well for that. But how can open source actually help all of your students, whether they're undergrads or graduates? Well, here's some things you can point out to your classes to equip your students with skills to become a scholar in open source and potentially a researcher of the future. So open source can help you find answers. It expands the potential knowledge pool beyond the department and beyond the professors within the department. If you have a particularly driven student who's asking a lot of challenging questions and really wants to be at the front of the class all the time, and you don't have time to go out and research those things and put in all that extracurricular to be able to make sure that you can give them something else to look at, there's plenty of open source resources on everything, from using IPython notebooks or Jupyter notebooks to every kind of coding language. The labels that we have on GitHub help you search those independently as well. So you can search, like, I want to look at projects in JavaScript. I want to look at projects in Haskell, if you really want to. So you can go through that. Also, open source really promotes group work. And I know that group work is a massive bugbear in the UK, at least. And I've seen our professors at Nottingham employing GitHub as a way of using group work to be able to get that like identity of who created what, who committed when, just having that collaboration to both protect the identity of people who are doing most of the work and also to be able to encourage people to achieve like the commits together and work together. And it really helps them understand a process that they're gonna then use in industry. Most places now will expect some knowledge of a version control system, and there are loads of ways that you can get into using Git and GitHub really quite easily. Also, using the project boards and showing that feature to your students will help them with understanding agile practices and methodologies that fit with that. So it means that their project management skills are leveled up. And that's something that's really handy to have just as an all-round skill. Another skill that we learned on the Campus Experts program was writing technical documentation. And anybody who's ever written code that has some kind of dependency and they haven't written how you interact with that, in an open source project, if you do that, it's gonna be really tricky for anybody to collaborate with you. And you're gonna get a lot of feedback to that extent, like, I didn't know how to do this, or I didn't know how to compile it, or what steps do I need to do, or what dependencies does this have? And you'll get loads of questions asked to you from the community. Writing really solid technical documentation in a README file is something that is an invaluable skill and all your students should learn, because then they can actually start to write programming, codes and stuff that are written in an accessible language that everybody can access and everybody can contribute to. And that's what practices you should be having. Otherwise you get teams where a developer leaves and nobody knows how to do something. The other thing that I really love about using GitHub in particular is that they have a particular flavor of Markdown. And I use this for quick and dirty writing. So you can see here that this is just got a few tags in it, but it actually renders out like this. I can use emoji, I can link links, I can add titles and lists and tables, all just through really easy Markdown. And that means I don't have to think about the formatting or get caught up on any of that, and I can add it all in afterwards. I can just type in my text editor, commit the file, and then choose how I want it to look afterwards. It's a really nice way of doing things. And the last thing that I want to tell you about, if you don't already know it, GitHub actually provides a student developer pack for your students. If you haven't told them about this yet, you should do, because it's so much free stuff. It's unbelievable, and they should be using it, especially because this means that every private repository becomes free. They're not limited to a number of private repositories. They can have unlimited, and that's really great, because otherwise I wouldn't be able to put my research and thesis on GitHub because it would be slightly risky. But yeah, and it helps me to collaborate with people. So just some tools. I hope that you've enjoyed listening to me today, and thank you very much. I'm going to pass over to John Pham now, who's going to talk to you about his experience with Git and GitHub in the classroom.
Hello, everyone. My talk is going to be on when should you introduce Git and GitHub inside your classroom. So my name is John Pham. I'm a third-year student at the University of California, Riverside. I'm an instructor, campus expert, and a web nerd. So the first thing we have to think about is the trade-offs. If we introduce it too early, are there any risks? If we introduce it too late, are there any risks associated with that? As educators, we need to think about a few of these questions and judge based off these trade-offs. So the first question is Git and GitHub hard for students? If it is hard, then what kind of support as educators can we do to provide support to help them learn? So is it hard for students to pick up? With the right support from us as educators, it isn't so hard. It's just like data structures and algorithms. They are complex topics, but with the correct support, anyone can learn them. This is a quote I got from a fellow peer of mine. It basically sums up saying that as educators who provide the correct support that help them learn Git, it's not really hard, and they actually find that it's very useful inside their curriculums. Here's one that might shock a few people. This is from someone outside of computer science. So Git isn't just useful for those within computer science. Today, code has reached into every other field. So the utility and the functionality of Git actually affects people outside of computer science. So is the right time for the intro courses? So I went around on my campus to ask this question, and it turns out that we should skip the intro courses. The intro courses should be focused on developing the students' core fundamentals in programming. It's meant to master the fundamentals first. If we introduce Git with that, it might complicate a few things. So how about the upper divisions? So here might be the perfect place. It's also important that we don't introduce it too late, because if we introduce it too late, the students won't understand the functionality and the real usefulness of using Git. So say if you introduce it in the capstone courses, by that point, they might have developed bad practices, and introducing Git at that point might not add any value to the students. So a really good course to introduce it is in the courses where the assignments no longer take a day to complete. It might be good to introduce it in the data structures and algorithm courses where assignments take a bit longer to do. So with that, students are able to track their progress. They're able to log everything as commits. And in situations when a update is made and their code no longer works, they're able to go back to a previous version that did work and see what happened. So what lines changed, and they're able to quickly see what happened. Another good place to introduce Git is in the courses that have group assignments. So the real value really shines through when students are working together. A core functionality of Git is it allows students to work on the same code base all at once. So this prevents students from sending their code via email. And really, when we're working with code, no one should be emailing files to each other. So I've seen some situations where students have two different screens open. One version is of their code, and another version is of their friend's code. And they're going line by line to see what the other person did. So that works, but that's us as programmers. We need to teach them ways for them to code efficiently. So with Git, like different versions, so say student A works on function A, and student B works on function B. They're able to see each other's version, and without going through the code line by line, they say, oh, you implemented this version this way, and you implemented this way. Your way is actually better. Let's merge your version instead of my version. So why work in Git? So why should students use and learn Git? It's useful because Git is used in industry, and we're training students we're trying to prepare our students to go into whatever industry or field they want. So Git is pretty useful. So as of now in the workforce, it's pretty assumed that programmers and even people inside the tech industry know at least one type of version control. Again, it's one of the best ways to collaborate. We no longer have to do the split screen, comparing line by line. We're able to see programmatically what's the difference in this code and what changes did we make over time to add additional functionality to it. So why work in Git as educators? So again, with Git, it's a version control system. You're able to keep track of all of your changes you make. So each commit you make, that's a snapshot of your code at a current time. So as instructors, this might be very useful because you assign an assignment to your students, and you want to see how do students start off. Do they start off with just writing it a brute force method, or do they actually spend time to write proper clean code? So with this, you're able to use these resources to tailor your courses. So say in lecture, you notice a bunch of students are writing a function recursively, but you intended to write it iteratively. You might be able to catch that early on and mention it inside your lectures. So why can't I keep using X? So what is X? So X is traditionally email, iLearn, Moodle, those classroom management systems. So traditionally, a lot of professors and faculty assign their code either through a PDF, and then afterwards, the students are expected to write their program, zip their files, and upload it to one of these services. So it works fine, right? We're able to see what students do. They're able to upload their code, and we're able to grade their assignments afterwards. But this process is kind of tedious. It's not meant for code. It's meant for essays. It's meant for other types of documents other than code. So also, no one at the big companies sends code to each other via email, or they upload files. You don't see big companies deploying their code by uploading a file to a server. Or they do that, but not through email. And then with the email, with emailing, like how do you know which version is the latest one? I might name my zip version 2, but yours might be version 2 of a later version. So how do we know which version is true? So with version control, we're able to manage all of that, and then there is a central source of truth. So I asked the CS faculty at my university about why they switched to GitHub, and he said they basically switched to GitHub after attending a SIGCSE conference such as this one, and they learned about GitHub. So he said, I cannot imagine why people are still using X if the assignments involve code. So before, this faculty member was using a traditional classroom management system, and in his experience, it was horrendous. So with Git and GitHub, it makes deployment, collection, and grading a lot easier. So how easy is it to use GitHub/Classroom as an instructor? So as of now, you might have a testing suite already for auto-grading your assignments. You're able to keep that entire system and easily move into GitHub/Classrooms. Another faculty said, with Classrooms, the process of deploying, collecting, and providing feedback to students is very easy. So as students learning how to program, feedback from instructors and TAs is very crucial. Because since it is programming, there's multiple ways to complete an assignment. One way might be very hacky. The other way might be proper. So without that feedback, students develop bad habits. And with GitHub, it's very easy to provide feedback line by line. So with GitHub and Classroom, you no longer have to log into a content management system, download every student's files, unzip it, then run your grading manually, then re-upload everything to provide the feedback. Another faculty member said, moving to Classroom was very low friction, a breeze. So this basically entails that this faculty member had a testing suite set up already, and they were using the traditional students upload their code as a zip file. The person will download all the zip files, then run the test harness. So even with the transition to GitHub, the entire test suite was able to stay. So this basically just changes how you, as educators, assign and collect assignments. Thank you. And next up is Chris. Oh.
Good afternoon, everybody. My name is Chris Cannon. I am the GitHub campus expert from North Carolina A&T State University. And today, what I'd really like to talk about is the story of how Git came to our campus. Just in the past year, we transitioned from having no classes and no curriculum related to version control to having two of our main pathways classes incorporating GitHub Classroom with several more with plans to integrate it in the future. And so just a little bit about me. I am a computer engineering student at North Carolina A&T State University. I am also an undergraduate teaching assistant, which gave me an interesting lens into this whole process. I work in our second level intro to programming lab for Java development, and that's where we actually targeted our first Git deployment. And I am a GitHub campus expert, and my site at the bottom, c3.tech, has all my contact information if you have any questions later. But really about me, what's really important? That stuff that actually matters. I'm an application developer. I'm a robotics engineer. I am a mentor. I am a teacher on campus. And for 6 months, I was an infotainment software engineer at Honda Research and Development. And that experience was absolutely crucial to me because it was there that I actually was introduced to Git for the first time. I'd never heard of it in school. I had seen the GitHub website once, and I think I downloaded a zip file. And that was the summary of my Git experience walking into this software development internship. And I was very lucky in that there was an engineer on the team named David who sat with me for about 2 days and answered all of my stupid questions about Git and what cloning meant and why I had to do it here and what a commit was and what should my messages look like. And that really shaped my view of Git, and really my first introduction to it wasn't in a class, it was using it in the job exactly the way it was designed to be made, and that really gave me a passion for it. Also, I took entirely too many awkward selfies in my work uniform. But what's really important is I got this passion and I wanted to bring it back into North Carolina A&T. So I researched several solutions for how we could integrate this into our classes, and there was only one that really stood out as having any sort of tools for education at all. We didn't actually use GitHub as our remote host at R&D, but I found that when it came to implementing it in a classroom, Github Classroom was really the only one that stood out. We had tools to manage student repositories, we had workflows that would support pull requests and allow detailed feedback, and most importantly, it was easy to implement and use. I could give the feedback to the students exactly where I wanted to, right in line with their code. And when you can give a student feedback right in line with the code, then your compliments become more sincere. They understand what you're complimenting on. They understand what they've done well. They understand exactly what they need to change. This communication with exact context was really invaluable to me as a TA. But when I settled on this solution, I had one more barrier that I had to cross. I had to convince my boss. Dr. Bryant, an associate professor of computer science at A&T, was actually very, very supportive of TAs bringing suggestions to him. And one of the first things he told us at our TA meeting was, let me know what ideas you have that can make this class run better, because you all have used it more recently than I have. And I thought that was a really impressive observation on Dr. Bryant's part, to see that he does his best to stay abreast of the newest developments in software engineering, the newest methodologies, the way that people are doing things now. But at the end of the day, he spends his time at North Carolina A&T preparing lectures and working to give the best education for students. It's us that are actually going out and spending 3 and 6 months at a time in the workforce learning these workflows and what's happening right now. And so he was very open to getting that information from us when we came back from our internships. And that's what gave me the confidence to bring him this plan. So my proposal was to dedicate one lab strictly to introducing Git and GitHub concepts to students. So at one time, we introduced enough where they could complete a lab on a single branch. We said, this is your repository, this is how a repository controls changes, this is what a remote host is, and this is how you interact with it. From then, we used GitHub Classroom to distribute lab assignments so students could get used to working on a single assignment during one lab period in one repository. And then from there, we expanded into these major programming assignments that we use. There are 3 major programming assignments that Dr. Bryant would assign throughout the semester. And he already had built into these things milestones and deliverables that students were to complete to get a certain number of points. But with the traditional education suite that we had to turn in assignments, there was really only a chance to give feedback at the end. So even though we had all these iterative deliverable items, students were still just throwing it into a black box and getting a grade at the end. What we were able to do was to split those deliverables into individual branches and pull requests so that students, if there was 4 different deliverables in the assignment, would get feedback from TAs 4 different times leading up to the due date to make sure, 1, they were going in the right direction, that if they had any hang-ups, those were addressed immediately. And it really kind of helps bring students into the funnel of how this assignment should be approached, instead of the, I'm going to sit down and write all the toString methods because I know what a toString method is, for data types that don't even work yet, which could be a little bit frustrating to grade. So that workflow really got the conversation started sooner about how their code was working, and it gave us a lot more opportunity to give real-time feedback. But then it got even better, because during the course of my research into GitHub Classroom, when I was trying to figure out, how do I do this? How do I set this up? How are people using this? I came across a program called Campus Experts. And Campus Experts kind of gave me the idea that not only could this methodology and these tools be used to enhance classroom experiences and improve students' capability for the workforce, but we could use technology to empower all these student communities on campus. Communities that maybe were struggling to have continuity, maybe were struggling to engage with everyone that was interested in this community. And that was a really interesting concept to me, because it's a code hosting website, right? Like, how does this help me build a community? But when I got into this training, which was one of the great benefits, what I learned was, beyond these technical topics, you could take leadership and community building skills directly into the actual Git flow. And that was crazy to me for the first time. So as I learned these things, not only did I learn technical topics, I learned about different leadership topics like how to present a workshop, how to organize a group of students, how to give feedback to people that is compassionate and useful and context-driven. But the first thing that we do in our training is we look at our specific community, and we're really encouraged to narrow down that community as detailed as we can. So rather than just saying, I want to make my university better, okay, that's great. But what matters most to you at your university? Where are you plugged in? What communities are you a part of? And what do those communities really need that we can put a timeline on and measure how you can impact it? And that was a really cool lens for the rest of the training. And then once we completed the training, we had the support and funding that we needed to make these ideas reality, which if there is one thing that try as we may in universities, we need all the help we can get with giving our students as much support and funding as they can get. And this is just one more great tool to get that to them. So I definitely want to reiterate the URL that Vanessa mentioned before. If you have that one student who's a real hard charger and just wants to get a bunch of things done and just has so much energy and ideas that they bug you during office hours all the time, shoot them to this URL, and we want to meet them and interact with them and help them implement all their great ideas. But coming back to why building communities with GitHub, collaboration is super important when we're building a community. But collaboration kind of exists on this weird spectrum from Google Drive, where you can either change everything and wreck everyone's whole world because you can change whatever you want, or you can only view it and you can't make any changes at all. And then on the opposite end of the spectrum, we have, oh, the president has a USB drive that has all the important documents of our organization, and he's got it because he's the president. And none of these models are really engaging for students, and none of them give students full access to the organization. So GitHub lowers barriers and raises standards for all sorts of collaboration, beyond just code, even into the actual organizational documents that run your student groups. So anyone that has access to this organization is more than welcome to suggest a change to anything from a group project, like some app that you're working on for just your group, or all the way up to the founding documents of the organization. But instead of that change just being made, it goes through the same review process that makes our best software products that the whole group can be a part of and give feedback on. It improves accessibility to the information, and it's scalable beyond what we're going to cover in our student groups, for sure. And the best part is, while these students are working together, without even necessarily knowing it, they're practicing enterprise best practice tools for free. So my last little bit is going to kind of summarize some of the impacts that I've seen on my campus. One of the big organizations I'm involved with is Aggie Robotics. And this organization was hard charging my freshman year, but then absolutely fizzled out when our president graduated in the spring semester, because he just didn't share any of the information with anyone, and there was no way to get it from him once he was gone. So in my junior year, a group of us got together with our department chair, and he basically expressed his willingness to bring this organization back as long as we would commit to being open with the information and making it accessible to everyone who was in the organization and making sure we had a solid plan of continuity. Of course, I thought, let's put it in a Git repo. So our organization repo on that home screen there holds our club charter, our policies, our standards of conduct, our roster, everything that we need to manage this organization. And it's totally open, and it's open to anyone. And anyone who's in our organization can suggest changes to these policies if they see ways to make things more accessible, more useful, better for their experience and better for the campus. And we all get a chance to review that together and make sure that this is the best thing that we can adopt for our organization. Let's implement it. Another organization I'm involved with is the Aggie Makerspace, which is a totally student-run and managed team that manages 2 different makerspaces inside our engineering buildings. We do everything from 3D printing to circuit board design to software consulting to anything that students would like to do. We're installing our VR development booth and our multimedia recording booth in the next couple weeks, which we're very excited about. But the idea of a makerspace is that we make making accessible to everyone, and that we share our resources and share our ideas and learn and grow together. So of course, I made a Git repo. And we have everything from makerspace policies, which I basically already summarized for Aggie Robotics, but we also have things where our 3D printer queue that tracks the incoming print jobs is an open source project that students work together in our Git repository. We also have a repository entirely of 3D models that students have made and printed in our makerspace, because GitHub natively renders STL files and students can manipulate and view these 3D models and decide if they'd like to print something as well. So it really is just a way for us to show off what we can do, which is great to help each other, and also great when it's time for our department chair to solicit funding outside of the university. So it really helps everyone on all levels. And it's already been mentioned several times, but employers want our skills. They want students who know how to use GitHub, who know how to use Git most of all. They want students who recognize these software processes. They want students practicing Agile. They want students collaborating with each other and collaborating in the same way that they collaborate in their day-to-day jobs. And the amount of times that a student who absolutely hated me when I told him he had to use a command line tool the first day of lab, who came up to me the next semester and said, look, I was in an interview and they asked me about my GitHub profile and I had something I could show them. So thanks for that, is just the coolest part of all of it. And we've really experienced the impact at A&T, and it's growing to more and more organizations. More and more people are coming to me and improving their collaboration through GitHub together. And if, again, c-3.tech, if anyone, especially in the North Carolina area, would like to reach out and get together, host a workshop, or just ask questions, please definitely let me know, and we'll be available for questions after. Thanks so much, and it is now my pleasure to introduce Elliot Whitehead from CU Boulder.
All right, hello. As he said, I am Elliot Whitehead from CU Boulder, and I'm here today mostly to share a little bit of my story with kind of my activity in my campus and my community. I'm here to talk about setting the stage for Git and selling students on version control before teaching it, starting with why they should even learn it to begin with. So about me, I am a developer advocate intern at GitHub. I am a student and campus expert at CU Boulder, and I'm also an organizer with a student-run developer community called HackCU, which is a small community of developers and designers and business students, and we organize a huge hackathon every year, which is actually happening tomorrow. It's a 24-hour hackathon. I'm flying back tonight for it, so that's going to be super fun. I'm also a community captain at Galvanize, which is a national developer boot camp where they teach students to become web developers over the course of 6 months. And I've been working with their campus in Boulder to teach their Git and GitHub curriculum. So across all that, I've taught more than a few people about Git and GitHub, and some of the lessons that I have learned are as follows. So here's kind of where we're headed. I'm just going to talk about some challenges with like teaching Git, some things that I've found have been difficult with students kind of like receiving the information. Ways that we can unlock student agency and sort of inspire them to want to learn it on their own if they need to, and allowing those students to then unlock the power of Git for their own career. So there's kind of two main challenges that I've come across with trying to teach people Git. And that's that, like, if you're just trying to present the information, like, they get distracted, which in lectures, which I've seen this at my school, lectures is kind of tough because, like, students have buzzy, flashy things in their pockets that go off, and if you miss, you know, a minute or 2 minutes of a, 50-minute Git lecture, like, all hope is lost. Like, that's all it takes, and you're just gone. So that's tough, and it's almost hard to blame them because it's just a lot to take in a lecture, like, hands-off kind of way. And Git can also be really intimidating, kind of what Chris was mentioning. It's a command line tool. Most students that are learning Git haven't really worked with a command line tool. Sometimes they have, but it's just kind of, a little bit more intimidating than some of the other things they've learned. But yeah, so before discussing those challenges of teaching Git, I just want to talk about some of the greater challenges, take a step outside the classroom for a second, some of the greater challenges of developing software. And so there's a lot bigger challenges out there as far as developing software. So one of the things I learned, this has been reiterated a couple of times, when I was in high school, I was learning to build websites. And I was using a USB to take my code home from class to my home to do homework and back and forth, because I didn't know there was this magical thing called Git. And I was sick for like 2 weeks. I don't remember how I got that sick, but I was out of school for like a solid 2 weeks, and I was at home doing all the homework, keeping up. Came back to class like that next week and plugged in my USB stick and had the two like file explorer windows side by side, and I think I got like distracted, like had to go do the warm up or something, and I looked back, sit down, and dragged my old files over on top of the new ones. Bam, just 2 weeks of work out the window. So that was pretty devastating. Fixing code that usually becomes broken, I saw this a lot kind of coming back to CU, where students will kind of build out like a whole homework assignment and not really stop to test it iteratively along the way, and then they'll be like, oh, something doesn't work. So it's like hard to know exactly when your code breaks. This one I've also seen at CU. A lot of students in computer science like to game, so they have these big gaming laptops that they're just lugging all over because they want to do their code on it, and it's just kind of a big pain. Finally, working in teams is really tough when you have to start trying, editing the same files, distributing your workload. It's a huge pain. And the reality is that developing software without version control is way, way, way harder than actually just learning how to use version control. So it's totally worth it. I went through all of those same experiences. Then after I learned Git, I was just like, why didn't I know this before? Like, why? But that experience is also really valuable in and of itself because, and that's kind of where I'm headed with this, is students should understand those problems first. If they don't at least experience it, they should at least understand that there are dragons out there. So basically, if they haven't experienced it yet, well, they may not have experienced it, like I said, but maybe they have. Maybe if you're introducing Git a little bit later on, like with what John was saying, it's important to just kind of reiterate, like remember when that happened back then, just kind of poke those wounds to remind them like, this is going to solve your problems. And it's our job as instructors to just make sure that they understand like this is, the value of what's going to happen. But at the end of the day, it's still kind of scary. This is the second challenge. It's a kind of a intimidating command line tool. It kind of looks like the Matrix. This is what's flying by on the screen. So there's some really awesome tools out there that help students that are more visual oriented. This is the same tool if you stop to buy at one of our GitHub workshops down at the booth. The top tool, it's a really awesome tool for visualizing like the branches and how all of that kind of interacts with each other in a visual way. Our GitHub Desktop App is a Windows app that basically allows you to use Git to manipulate your repository and make commits and do all of that kind of in a very visual way without having to use the command line at all and sync your changes up to GitHub. There's also a wide variety of IDE tools built into different text editors like Atom, which is GitHub's text editor, IntelliJ, JetBrains, those kind of things. So aside from these, there's something else we can do to make Git appear more welcoming, and that's with philosophy. So now we're going to talk about Stoicism. All right, so I'm a huge fan of Stoicism. If you don't know, basically it is a life operating system for happiness. And if I were to boil it down to a few words, it's essentially the practice of understanding that things could always be worse. And at least for me, when I was learning about GitHub, it really had a lot of value to go and look out about. That's kind of how I learned. It was like, okay, here's this thing. Why did it come to be? Like, what problem is it solving? What was there before it? And so I went digging around and found some things. And one of the main kind of towers that Git came and toppled was something called subversion. And I'm getting ahead of myself. But anyway, so it could always be worse. And SVN is worse, subversion. So basically, Git, what's really cool about Git is, it allows developers to work offline, concurrently, what's the word I'm looking for? Remotely, which, if you want to sell your students on the idea of working on a beach doing software development in the Bahamas, you're not probably going to do that with Subversion or something older. So Git allows us to do that. Yeah, so all the cool kids are doing Git these days. And it isn't just like an ugly, dull command line tool. It's actually like the hip new trend that is here to save us from ourselves. Yeah, that's all about that. So basically, the idea here is that if you've painted the picture correctly, students should be sitting on the edge of their seats waiting to hear about the solution, and it's Git to the rescue. And this has been iterated a few other times as well. It's just such a valuable job skill. And what I really like about Git and why I am happy to invest time and even money sometimes into learning and mastering Git as a skill. It's a little tough in computer science where there's so many different web technologies. I mean, you look at JavaScript and there's like a new framework coming out every 2 weeks and it's just hard to keep up with. Git is one skill that you can learn and it will be useful everywhere you end up in any kind of industry. Because I think it was Amy that was saying, there's people not in computer science at all that use Git. I have some friends who are civil engineers and they use Git to version control their MATLAB code to run their structures analysis. And I just did a quick web search for software developer, but this goes across the board and just everyone wants to see version control. It's either a requirement or like a nice to have for students that are incoming for internships and jobs, and you just can't live without it anymore is the reality. So ultimately, context is everything when teaching Git, kind of setting the stage for informing students how valuable it is and that it's for their own good to learn it before you even try and teach it to them. Just you want them to be salivating to hear the gospel of Git. So yeah, set your students up to win and they'll be happy too. So thank you.
Great. Thanks, Elliot. Just a few things to close out. If you want to teach with GitHub, but you're not exactly sure how, we have developed a teacher training program called Campus Advisors that is available at education.github.com/advisors. There's 4 modules, they're all online, you can take them at your own pace. They all address classroom contexts. So we start with Git internals, individual work, group work, and then student programs. So if you're really excited to implement examples like the students did, or your students are clamoring for Git and you want a little bit more support, now you can find it. That's live. And lastly, this is not for the public. This is just for teachers at SIGCSE. But GitHub has put together a package for you to get everything GitHub that you need for your entire school for free off the shelf. And that's free GitHub, the Student Developer Pack, Github Classroom, Campus Advisors, all the free GitHub you need. And you can find that at education.github.com/schools and all the information about that. If you would like more detail about that, there are 2 more sessions where I'll be talking about that tomorrow morning, one at 10 and one at 11 a.m. down at booth 205. And you can sign up for an appointment at calendly.com/mozzarella. That's my handle. And I think that the students are going to hang out just for a few minutes for questions, and then we're gonna wrap it up because they all have flights back to get back to their student life. Thank you so much for coming. They'll be up here if you want to ask them questions. Thank you. All right, you're free. Thank you. Well, wait. High fives. You gotta have your hand out. You ready? Drive-by high five.